Hello students, this is the rectification of question number 5 from the video. Question number 5 part C. As you see that we have to draw 3 crests of the wave reflected from the barrier in this question. And we also have to indicate one wavelength. Now we'll solve the question first and then we'll talk about the concept. So one wavelength is just the distance between two wavefronts. So this is basically one wavelength, right? Question number part 1 is done. Part 2, we have to draw 3 crests of wave reflected from the barrier. So we see that there are 3 incident wavefronts, which we see over here. The reflected wavefronts will be also semicircle and they will look like this. The only thing which you have to observe and keep track of is that the distance between 2 reflected waves is exactly equal to lambda. And like this, we have to draw 3 such wavefronts. So the approximate distance between them is again lambda. And that's how you answer the second part. However, let's go a little deeper into the concept of why are we drawing or how did this reflected wavefronts came into existence. So basically we are talking about laws of reflection, which means this is a point source and let's draw incident rays first. So the incident rays will be like this. I'm drawing 3 of them, this and this. Now, please note that at every point of time, the incident ray and the wavefront are always perpendicular. So this will be perpendicular. And what does the law of reflection state? It states that the angle of incidence, so if this is the incident ray and this is the reflected ray, this is the normal, then the angle of incidence is always equal to the angle of reflection. Let's try and draw reflected rays for this particular scenario. So the reflected ray for here would approximately be, something like this. This one will be like this. And the one which is incident normal to the surface will also reflect along the same, it will retrace its path. So it will look like this. These are the 3 corresponding reflected rays. Let's get rid of the incident rays. And let's try to extend these reflected rays backwards beyond the barrier, right? What do we see? We see that the 3 rays will approximately, so let me do the extension properly. The 3 rays will approximately appear to come from somewhat over here, a source S dash, okay, which is approximately again equidistant or the same distance behind the reflecting surface or the barrier, right? So S dash is at the same distance away from the barrier as S is in front of the barrier. Now, if this is our reflected source and if we have to draw wavefronts, how will we draw? The reflected wavefronts will again be semicircular. Now, although we are drawing only 3 rays, please remember that there can be infinite numbers of rays possible. So the reflected wavefronts will look like this. Obviously, the wavelengths will be same because it's of the same source. The reflection is happening of the same source. And this is how the reflected wavefronts would look like. Obviously, in your exam, you will not explain all this and you will not draw the reflected source. So all this is not required. But of course, you can always draw the part which is in front of the barrier, which the question asks. And that's how this question is answered. Hope you understand. Thank you.